Hi, Yas. Thanks for the great introduction. Today we'd love to talk to you about this idea of a black box. So in brief, the outline looks like we're going to actually explain what we mean when we say black box and black box analytics. And then we're going to go into why, here at Alpine we feel we really need to take analytics out of this black box. It's really not a mystery, and we should really discuss that. And then we're going to go into some recommendations on specifically, how to take steps to get yourself out of the black box and open this up for the rest of your organization. And in that, we'll talk about some key principles that we'll go into to keep in mind when you're starting this journey. And finally, we'll go into some specific examples of how here at Alpine we address this idea of getting out of the black box. So let's get started. So why is analytics a black box? I think there's a lot of history here that Steven and I will go into in some discussion. But specifically, when we say black box, what we mean here is there are inputs like data or knowledge or information that goes into some box or some area where there's a process or there's a synthesis being done, and then there's a certain amount of output that comes out. And that output is later used to drive business decisions and other factors for your organization. And analytics specifically is traditionally done with this inscrutable, standalone, siloed applications, in different areas of your organization, or with some custom code that makes it very challenging to understand specifically how that's actually being done. And in fact, we actually take it a step further, and we talk about the full kind of analytics workflow. And here, there's actually not just one black box, but there's actually many. So in essence, in this analytics workflow, there's the data collection black box. So what I mean by this is really, when you start looking at data that's flowing into your organization, we really today just kind of accept this data as it is without having any sort of knowledge of how it's coming into your organization. For instance, you may look at clickstream data and start actually analyzing it without actually having any knowledge about how that how the website is actually maybe set up, or how that data is kind of flowing in. And second, we talk about data transformation. So now, using the same example, you may have that data flowing in, and then it's essentially handed off to someone to essentially aggregate it in some way. So, again, with clickstream, you may want to know, for instance, how is that data really being transformed, right? Today, we kind of throw that aggregate data over the fence to the analyst or data science team where, for instance, the definition of a session may have not been well defined or just assumed to be defined, or the definition of a unique visitor is not really fully given to you as defined. And you have no idea of how to peer into that world, or you're not involved.
Yeah, I think that's sort of the original black box in some senses is the collection of data. It's surprisingly common in my experience that the analyst or the data scientist or the business user who's the recipient of an analytics study often can't actually reproduce the inputs into that model in the first place. In other words, the way that the data set was created, the way that the website in your example was instrumented, the way that the original analytic data set was plugged into your analytics engine is often lost, literally lost. The set of transformation scripts or cleansing scripts that created that analytical data set for the modeling process is often sort of discarded, and the starting point is regarded to be the analytical data set. So there's a provenance problem here, I think, which is that often you don't know how to recreate the steps that got you the model in the end.
Yeah, that's great, Steven. And, taking it a step further, then we talk about actually when you start trying to construct models and start doing mining that's also a black box. Steven, do you want to give us a comment around that one?
Yeah, I mean, arguably this is a controversial point, right? I think lots of people would argue that it's totally fine that it's a black box. So you send off your business problem and a bunch of data to your friendly local data scientist and hopefully get the best model that you can out of that. I think that's wrong. I think that those both downstream and upstream of that process should be able to weigh in on the modeling process. In other words, modeling is in a sense a sort of an art. It's a human process. It requires understanding the business. It requires understanding the underlying data. And I think actually having formal processes of model review, data reviews is not only ideal, it's actually critical. In other words, often the business users, the data engineers who collected data in the first place, the executives who are going to be kicking off these projects, obviously have an intense interest in what these models are doing, and they should be allowed to review them, and there should be some transparency about what the data science is actually doing in order to understand how it's going to affect the business.
Great, thanks, Steven. And finally, we talk about, once we do develop, these advanced and complex models, oftentimes people view this in the last stage of how do you deploy this, right? Are we deploying this as simply a recommendation to the business? And then that kind of goes into its own world or its own black box as well in the business world. So for instance, you may see certain traffic coming to your website from a different referral, and so that's taken as an insight for that given day, week, or month, and then the strategy is updated. But the folks involved in that process up until that point don't necessarily have visibility into how action is being taken on those insights. Furthermore, you may deploy this as what has been coined the term a data product, as DJ Patil has kind of spoken about in the past, where, for instance, on People You May Know with LinkedIn, it essentially takes that model and then goes in and gets coded into the product itself. So there's an army of engineers, or there's a development team or product team that's also taking that information and acting on it. But as far as maybe the modeler is concerned, or the database engineer is concerned, they may not have complete visibility into that black box as well.
It's a slightly different example of the black boxiness of deployment, but it's kind of one of my favorite horror stories. This is from a few years ago, but not that long ago, and this is a major financial firm that I was working with that I would say is definitely a strong practitioner of data science and the use of models for things like fraud detection and so on. And in that particular case, you had a large-sized team of data scientists producing models using a popular modeling engine, analytics engine. And then those were deployed by this army of literally hundreds of SQL engineers. So any model that was developed by the core team of data scientists that was used for, say, product offers or fraud detection, whatever, credit approvals and so on, had to be converted into production mode by this group of SQL engineers who were literally converting manually from the code in the original analytics engine into SQL code that could run in the database for scoring and driving campaigns. So that's a very error-prone process. There's no real communication between the data scientists and the SQL engineers to determine if that model is going to be sort of efficient, and arguably it's just not the right way to do it in the first place. You kind of want to break apart both of those black boxes and try and make that process much more iterative and efficient. So models don't take 2 months to deploy.
Yeah, no, and that's definitely something that we can talk about here. And I think if we pull it back to analytics specifically, and we talk about how it's strategic to your organization, as Steven just mentioned, I mean, when you do have these black boxes, there's a likeliness that it's going to be very error-prone, or much more prone to error, in the sense that there's far less transparency. The other thing to consider, and why we should take it out of the black box, is that it's truly a multidiscipline activity of getting the most out of your analytics. as you include more people into that process and have understanding of that analysis, then you're likely to find things that you probably wouldn't otherwise. In addition to that, today I think there's a bit of, confusion about essentially, what advanced analytics means or predictive analytics or data science. And as we kind of move further in that direction, things get really complex and really hairy. We start talking about very advanced math, using very advanced statistics that become far, more complex where you really need help. So, as that complexity increases, that also increases the likeliness of risk. And finally, as also Steven just mentioned, there are many stages to this. Not just in terms of how the data is moving through the organization, but also how the knowledge is being transferred and created and how the model is being developed. And we'll go into that in a bit more detail in a moment. So, given that, now we'll actually point at some specific examples of where, the black box has kind of gone awry. And one example that we found, and it's a bit of a dated example, but there's been quite a lot of analysis done on this. There's actually a research study at Berkeley where they actually did a kind of review of this situation that happened in the late 90s. And specifically, this was in the financial sector where there were some essentially very, very smart individuals who came up with essentially a fund that was called the Long-Term Capital Management Fund, and essentially they found a very smart way of hedging, long-term and short-term bets and creating arbitrage using a very advanced model. And the understanding was that yes, there's risk, but they thought that they understood this very, very well. And so one of the things that ended up happening is that their historical correlations that they found, where they thought there should be a convergence, actually turned out to be divergent. And so over a short period of time, they started out in the first few years creating huge return on investment, and actually this was one of the hottest funds on the market at the time. But what they failed to realize was that they hadn't done any sort of stress testing. There wasn't really any transparency into how that fund was really being managed or how it was really being creating value. And essentially at the end of the day, things didn't go as planned. The model didn't keep up with the actual environment that they were operating in, and they ended up diverging completely from what their expectation was, and ended up losing some $4.6 billion in only 4 months. And this was one of the earlier examples, I think, of a financial black box and what can go wrong, and really threatened our financial system at that time. It was one of the earliest examples that I could think of. And as you well know, this has come back in recent times, and there are still black boxes that I think we're starting to do more to try and put in some sort of regulation. But in reality, I think it's also a cultural shift. The final thing I'll mention, on this use case was specifically that, there was a certain cultural trust with the individuals who set up this fund. Honestly, they were essentially Nobel laureates. So I don't think, and I don't feel that, people really felt comfortable poking holes in their analysis, and so there's a certain amount of trust there. And I think as a community, we need to go further and really challenge these models. With that, I'll hand it over to Steven to go through another use case.
Yeah, just to maybe round the point home a little bit further, a couple of my favorite examples when talking about sort of subtleties about the modeling process. There's, of course, many people on the call will already be familiar with the classic example of money, income, and sunspots, a paper by a couple of folks at the University of Rochester. In a sense, what they're talking about in this is a regression model that shows the relationship between income levels, and the amount of money in the supply. the amount of money in circulation. And there's a simple linear model there, which can be determined through regression. But what they did to illustrate a couple of points was to look at a similar regression, in this case not income against money, but income against the number of sunspots appearing over time in a time series on the surface of the sun. And they actually showed that you got a perfectly decent model, just as you did when relating it to the money supply. Now, the overriding point of this paper was really to talk about how you can blow apart false correlations like this in time series by looking at deltas between the points of the time series, say in this case the level of sunspots, rather than the absolute values. Because in this case income was just generally going up, so was the money supply, so was sunspots, so you got this sort of spurious correlation. If you look at deltas in between them, then it's not so easy to make that error. But I think that one thing that really comes out of this paper is the importance of intuition. Obviously, this wasn't a real-world example. I'll get to one of those in a second. But it can show you how, if you just throw a bunch of variables, whether those be sunspots or the Dow Jones or your favorite baseball scores, into a model, you're often going to find correlations that just simply are not meaningful. So the importance of having model review and intuition and looking at the underlying problem and trying to make the model reflect reality is an obvious point to make, but I think it's still an important one. Another example of this that I think illustrates a couple of different points was from my own work a few years ago, working with a beverage manufacturer and modeling volume in Japan. What we had in this model is a number of input variables into the econometric model, into the volume model. And one of those was the level of print advertising that the company was doing to promote this particular line of products. And if you looked at a fairly narrow slice of data, the training sample that we were looking at here, it looked like a pretty decent sort of linear relationship between the amount of money being put into print and the volume that was coming out, all other things being equal, as you got in the regression. So that was just fine. Well, later on, when we were actually pushing the model out into the real world and doing simulations and looking at out-of-sample data, it turns out the company had actually decided to move a lot of money out of TV advertising and into print advertising, partly as an experiment, partly based on intuition. And the model just absolutely blew up at that point. When you multiplied the investment you were making in print, which had historically been quite low, by literally 100, 200 times, the model just blew up, and we were actually predicting sales of the beverage to go up to like larger than the number of atoms in the universe or something insane like that. So we took a careful look at what had gone on here. Turns out that anybody perhaps with a little bit more experience, or maybe even just a little bit of intuition about the stuff, is probably not going to use a simple linear relationship between advertising and volume. They're going to use something like what typically an ad stock, often a log transformation, is going to be used here, and that would have prevented the model from blowing up and probably would have been a little bit more realistic based on typical patterns you see between volume and advertising, sales and advertising in the real world. So this invited some serious searching, soul searching for the organization that I was working for at that point. And we ended up making a number of changes, and I think two of them are worth pointing out pretty concretely. Number one was the institution of regular model reviews. So just as software engineers will regularly do code reviews just to get another pair of eyes, it's not like you don't trust your engineers, but often two heads are better than one, and you want to get engineers looking at each other's code to make sure they haven't made any obvious errors and have been thinking about architecture correctly. We instituted model reviews. However, the model review wasn't just between two data scientists. As time went on, we found that having a model review that invited in everybody on the team, even those who were not trained in data science, was an enormously powerful thing to do. It was almost just like one of these sort of emergent properties where just having more people around made the modeling process better, but often business would have an intuition, such as, for example, the lack of returns you get at a certain level with advertising, and being able to cap out those variables or use transformations. May not have phrased that in the language of mathematics, but did it in such a way that that was useful for the modelers to learn about. So those regular model reviews turned out to be not just critical, but a core strength of our modeling process at this organization. The other thing, of course, as Joel was pointing out in the previous example, is the importance of stress testing. So we instituted a process not just of upping the levels of the input variables and seeing how they behave, but we actually introduced that in an automated way. So all of our models automatically were subject to an automated process that would lift the levels of variables to something like, I can't remember the details, but something like 10 times their amount in the input sample to see that things at least remained vaguely sane. Or at least if you did get outliers, that those made sense. So an automated process of doing stress testing of models was something that we implemented, and that made a huge difference. It exposed weaknesses at the corners of the models that were very useful to see.
That's great, Steven. Yeah, I can totally relate. I mean, I can't imagine how many times I've been in a boardroom where you've gone through this whole analysis and you get there, and then someone kind of raised their hand and said, did you vet this? Does it actually make sense in reality? And oftentimes the answer is no, unfortunately. So I guess now we want to know, essentially, now that we've kind of convinced ourselves that we need to kind of create this sort of environment, get ourselves out of the black box, where, Steven, would you say, would you start?
So here's just a few pointers, almost at random, but I think they're maybe important ones that I've seen in the last few years in the realm of sort of managing data science teams. First of all, as we've sort of been hinting, I think you want sort of taking the sort of principles of Agile, perhaps, is the idea of a small sort of integrated team that's working closely together on the same projects. So, one of the things that the Agile movement has taught us is that having everybody working closely together and doing regular reviews is just a powerful thing. Everybody from engineers to QA to product managers to the business. So I think in my mind what this means is that you've got a data engineer, you've got data scientists, you've got business analysts, business users, all of those people working together in a small team with regular daily, if not weekly, check-ins to take a look at what's going on. That leads me to the second one, which is sort of having an agile process generally. So I know what people on the phone would say, but in my mind, analytics projects rarely end up where they thought they were going to end up. Even more so than, say, a software engineering project. I mean, again, the lesson of Agile is to say, well, your original requirements are going to end up changing over time. That's true like 1,000 times more in the process of doing an analytics project because, the data is going to tell you where to go. You may start out thinking, as in one project that I was working on a couple of years ago, probably a rather extreme example, we started out building a churn model and found out by looking at the data that there were some strong correlations that suggested that certain products were much more likely to increase profitability for the organization. We ended up building a product recommending engine. And it was really just by looking at the data that we determined sort of what the most profitable avenues of exploration were going to be. So I think being open to sort of course correction and having the business involved at every point, reviewing the data, reviewing the models can be powerful as well because it's often going to nudge you in slightly different directions. Also, the metaphor of the war room, I don't literally mean, although it can be useful, having a single physical location where people are working together on this stuff, but I mean almost metaphorically, you really want to have a single technical stack for doing your analytics. So as we were hinting at the beginning, often the analytics environment is going to contain a number of databases, it's going to contain maybe a Hadoop infrastructure, it's going to have analytics infrastructure, maybe a sort of separate parallel analytics environment where you're actually taking samples and building your analytics models. And then there's going to be some, often separate as well, process for deploying the models, as we were talking about before. In my mind, obviously we have a little bit of a bias here at Alpine towards this, but in my mind it should be a single, open, sort of transparent platform. In other words, you don't have separate apps that require copying files via FTP sites and CSV files and ADSs floating around all over your organization doing God knows what for your security. I think you really want just one single platform, a single web page you can go to where you can explore your data, build your models, and deploy them into production. And then finally, speaking as sort of a sort of lapsed mathematician from my research days and having gone into data science, I realized that in some ways it's possible to be fooled into thinking that this stuff is sort of like monstrously hard and just too difficult to explain to the layman. And I just don't think that's true. I think that models and even code should be scrutinized by everybody on the team. And as much as you can sort of summarize your analytics workflows in a single or a set of visual workflows that can be reviewed by the team, the better, because often you're going to get insight from the rest of the group there. So again, it's going back to this process of doing code reviews and so on.
That's great, Steven. And I just wanted to make a shout out. We're doing some polling questions. We're really interested to hear what you guys have to think. And definitely, it looks like here, from what I can see, that most people are considering only a couple models in general from this last question. But we'll review these questions in more detail at the end of the presentation. And what Steven is essentially saying is really great. And I've tried to summarize this in some key principles that you can use as kind of guiding you on your journey. So what I've basically talked about here is, as you take these steps, one principle is really to ensure reliability. So as Steven mentioned, I don't necessarily feel like sending, data files around your organization via email or dropping them into some FTP site is really that reliable. Additionally to that, as you develop models and as you develop these review practices, you essentially want to build in this sort of, quality testing, stress testing, performance testing, as we've discussed. And next, we really look at transparency. I feel that there's been a lot that's been going on in the industry and the environment to talk about transparency, but I don't think there's been a whole lot actually, been done. So when we speak about transparency here at Alpine, what we really mean is making, these complex algorithms and this complex process, visible to your entire organization. And I feel that we've done, a pretty good job of doing that ourselves by, making a very code-free and visual environment. And as Steven mentioned, this idea of being agile or really being flexible, because as you all know, things happen today in real time. What really goes on is, if you recall from the Super Bowl last year and when the lights went out, Oreo, I believe it was, did a really good job of basically capitalizing on that and creating a commercial. So this idea of really being agile and modifying your algorithms and modifying your analytics workflow, with your market and with your environment, I think is really key. And finally, always keeping your business in mind. What is the key outcome that you're trying to drive? What is the key value that you're trying to create for your business? That's the other guiding principle that I would focus on. And with that, we're going to go into some very specific examples related to doing advanced analytics and things to look out for when you're opening this black box and getting really into the details.
Yeah, I thought it would be kind of fun just to go down to some very specific examples. Again, almost sort of chosen at random, but just sort of off the top of my head, things that you may commonly run into when doing an advanced analytics project, and things that maybe if you're treating the whole modeling process as just a black box, may be an issue. So one example of this is sort of, I guess some people call it inductive bias, or just sort of the assumptions of the modeling process itself. So some obvious examples here, well, one very obvious example, right, would be doing something like a linear regression, where you are assuming that there is a linear relationship between the input variables, possibly after transformation, and your dependent variable, and other sort of assumptions in the regression model, such as the normality of the errors. Those are important things to check. You should make sure that obviously those get reviewed, especially things like error normality, looking at the residuals in your modeling engine, and ideally your analytics application should do that automatically for you. By which I mean it should immediately display your residuals so that you can take a look at these things and figure out whether your assumptions in using that model are correct. Another example, independence assumptions in naive Bayes, for example, and assumptions about maximum margin in support vector machines. You should know what assumptions your model is making, and make sure that those are true in the process, and ideally work with analytics applications that help you validate those as easily as possible through charts and statistics that are displayed to you. Another way to get out of the black box is to explore the sort of the hyperparameters, if you like, of the model. So I think that so what I mean by this is, so for example, if you're doing something like, regularization in a regression, varying the degree to which you're sort of penalizing can be a useful thing to do. And if you have multiple parameters into your model, for example, in a forest, something like the number of trees and the size of your sample, for example, the number of features to take into account at each node of the tree. Those sorts of parameters can be varied to give you different outputs from your model. And typically people will use things like grid searches or random searches through those parameters, so that you're not just sort of accepting the defaults, but playing around with those a little bit. Things like normalizing and scaling data is obviously very important. If you're doing something like a k-means clustering, for example, or something where you're measuring variance, like in a principal components analysis, there are many examples, even sort of regularization I was just talking about, where normalizing the data up front is something that's very important to do. And again, I would make the point that as much as possible, your analytics application should help you to do that, to sort of remind you politely that you may be wanting to do these things for the algorithms that you're using. Definitely taking into account the origins of your data. Excuse me. I can think of one example where one of our models, this is kind of embarrassing, this is not Alpine, I hasten to add, we're looking again at sort of sales volume, and at a certain point we're actually, so these are sort of point of sale volume figures, and there's a decent number of variables in the model, and we're actually using shipments and inventory levels, that's right, inventory levels as one of the input variables. Probably not a good idea, not something that you're easily going to be able to control for, and there's probably going to be a pretty strong correlation with the amount that you're actually selling, at least in some lag sense. So you want to be very careful that the causals and the variables that you're using, being aware of where they came from, and if, in some cases, they might actually be tightly correlated with the thing you're trying to predict. I guess that's kind of an obvious one. Looking at outliers and being aware of those, again, many analytics applications will help you to exclude those. If you've got something like say sales suddenly being unaffected by a temporary dip in your price, or a temporary increase in your competitive price can maybe throw off the model, or if you've got actually erroneous data, that can definitely happen, and that may screw your model up a little. So you have to be aware of those and look for those outliers, and ideally automate that process as much as possible. A couple more examples, keeping in mind the runtime and the complexity of the model. How long does it actually take you to get this model out of production? I think there are numerous examples where people will build churn models, for example, that take so long to produce and to push out that customers have already churned by the time you actually push those models out. And so you end up predicting not whether somebody's going to churn, but whether they're going to churn in 2 months' time, which is obviously not ideal. And so, I'm a big fan of super simple models that you can roll out to production very quickly, that you can build very quickly, rather than sort of fussing over the very, very best model that maybe is going to take you a few more weeks to get out there into production use. And maybe the most obvious thing to do, is making sure that you use the right model for the application. Here, I think, is another example where simplicity of the model may be more important than using the very latest state-of-the-art thing. That's cool to do. It's fun to play around with this stuff. But if it's hard to implement, if it's hard for the business to understand, then maybe it's not the ideal thing to do. I mean, for me, half of the value of a model is what it can tell you about your business, not just in its ability to predict. So if you're using something where the internals or even the outputs of the model are a little inscrutable, that may be useful, less useful than a simple model that is easy to understand and easy to push out to production.
Great. And Steven, now do you want to explain how Alpine positions themselves to actually...
Well, yeah, sure. We'd be remiss if we didn't sort of talk a little bit about sort of what Alpine does in this direction. I'll keep it brief and simple. One thing that we do is through a simple web interface that allows you to search all the work you're doing, we've really sort of blown it apart and made it very, very transparent. So in our system, there is one place you go to which has access to all of your data sources that allows you to search and sort of index and search that data, but not just the data, also search people, search comments that people have made, search your models, search your code, search the outputs, search the graphs, search the documents. Make sure all of that is searchable so that now, with appropriate security things taken care of, your analytics environment is completely open to the whole organization so that there's no duplication of effort and so that there's scrutiny and there's transparency. So I think that's an important one. Secondly, we try to go as much as possible for a visual approach. Certain cases it's always going to be important to write code, but as much as possible when there are common, repeatable model types and transformations and subflows and standard approaches for cleaning your data and modeling your data, you want to have that be done in a visual way that everybody can easily inspect so that things that can be reused and things that can be opened up to scrutiny and review can be done in as visual a way as possible. Next one is we've introduced this notion of being able to comment and share code and models and so on. So everything within the Alpine system, and we think this should be true for any analytics system, should be something that can be shared and commented upon almost sort of in a social way like this, so that things that are important, things that need to be documented, get that level of attention. A couple more things. We try to make model configuration as simple as possible. You'll see here on our just a couple of simple examples, right? On our PCA, we'll try and do the normalization for you and do that as a default. When we're configuring our random forest, we can actually search through the parameter space and figure out what the optimal settings are in an automated way, so that much of the configuration is taken care of for you, but still made clear, still made evident through the interface, so that it's very clear what's going on behind the scenes. In short, what we've tried to do is to say, yeah, there's a lot going on here, lots of different choices to be made, lots of parameters to twiddle, lots of models to be chosen, but through a combination of help, automated configuration, and bring the whole team together into a single web interface, we've tried to make it as open and as straightforward and as transparent as possible.
Great. Well, now I think we're ready to go into Q&A.
Right.
You guys ready?
If you have any questions, please submit your questions through the chat. So we have several questions for Joel and for Steven. The first questions we have here are, how are we considering static models compared to dynamic models?
Yeah, good question. So I think those terms can have a number of different meanings. In my mind, perhaps the most useful thing to say about this is that it should be entirely possible, if not automatable, to look at the way your models are behaving in the real world and to update those in essentially real time. So what I mean by that is there's a good example of this, and I think this is published actually. Procter & Gamble sort of led the way in this with, I think they call it the Sense and Respond program, where they were pushing out different things like pricing models and so on, to their stores, to their retailers, to their manufacturers. And these models would sort of measure demand, they would measure inventory controls and all this sort of thing. And what they would do is they would measure the efficacy of these models on a, I can't remember, daily or weekly basis, very, very regularly. And if you saw any drift in the models, you actually then rebuilt those models and pushed the new ones out there. So I think, again, sort of going along with this idea of having sort of a transparent open system where everything is part of a single stack and everything's sort of wired together, and the modeling process is not divorced from the data gathering process and is not divorced from the deployment process and so on. What you can aim for is something where you're not just pushing out a simple, static, fixed model every few months, but instead going with something that can actually be updated in real time, if not very easily and very regularly, almost sort of lights out.
Then the next question then is, how much volume of data is Alpine capable of handling?
Well, that's an interesting question. That's kind of a fun one to answer. I think it depends a little bit on the algorithm. Maybe the easiest thing to say is to say what we typically do in terms of data sizes that we handle at our client site. So certainly the application abstractly has been run. I think the largest cluster we ever ran on was certainly hundreds of nodes. And there we're running through billions of rows of data. This was a Hadoop cluster with many hundreds of nodes. And certainly then you're running through data sets in the case of billions, where we were running, I think in this particular example, 3 or 4 different models that we were comparing one against the other to see how they would perform, and that ran in about half an hour. So we were running something like, I forget the details, so excuse me for that, but running something like a forest versus a regression, logistic regression, versus, say, SVM, and we ran that on this very large data set to compare the efficacy of those models one against the other, and that ran in about half an hour. On something like where you have literally hundreds of millions, if not billions of rows, I think that's decent, and that's sort of the levels that we can certainly scale to. But I don't think that's typical, to be perfectly honest. I mean, in our clients, we're certainly handling tens and hundreds of millions of rows of data, but we've definitely gone beyond that.
Great. The next question is either for Joel or for Steven. What would be your recommendation as far as the right model for dealing with unstructured data applications?
Well, that's a difficult question to answer, to be honest. I think it depends very much on, if you're talking literally about a model, I think it really depends on what the business case, on what the use case is going to be, and what the data is, what it is you're trying to predict, and so on. I mean, certainly there are cases when dealing with sort of textual data, for example, where you can go with something as simple, when you're trying to do categorization of text, of documents, where you can go with something as simple as something like a naive Bayes model. We've done cases, one not so long ago actually, where we were doing classifications and we used support vector machine. And support vector machine was very nice because in our particular implementation, it could handle very wide data sets. Random forest can also be very nice for handling large numbers of features in this case, which is often the case when you have these sort of unstructured or sort of textual data, because again, it can handle large numbers of features by winnowing those down at each node of the tree. It's a good question. I think it depends a little bit on the context.
Yeah, we did some analysis as well where unstructured, it was actually semi-structured data where we looked at some clickstream data, we parsed out a bunch of URLs, and then we actually kind of continued to push that to the domain level. And we were basically using k-means to then cluster around those different domains to see kind of the behavior of users. And I think, that unstructured question, I think you essentially kind of pull that into the model and into your analytical workflow. Great.
The next question comes from Jing. The question is, how do you interface with disparate data sources? Steven?
This is an important one, actually. It's certainly not the most glamorous part of the data science process, is dealing with all these different data sources, but I think it's an important one, and the more that this problem can be solved, I think the better life is going to be for the average analytics team. How do we interface with disparate data sources well, the way that we do this in particular at Alpine is that we actually... a couple of things I think worth saying about this. First of all, as much as possible, we try to push the processing down into the source system itself so you don't have to move data out of those source systems. So whether that's a relational database or whether it's sitting in Hadoop, we can actually push that processing down there. Now, if your data itself for a particular model is going to come from a number of different data sources, then at least in the Alpine world, you're still going to have to move some of that data around to the place where you want to do the processing. So, for example, one of the features we have is we allow you to search across your data sources, whether that be like a SQL Server instance or an Oracle instance or whatever, find the data that you want, and then easily move that using parallel data import mechanisms into, say, your Hadoop data science sandbox. Increasingly, what we're seeing is that Hadoop is being used as this sort of sandbox where you actually do your analytics. And in that particular case, what you want to do is to be able to bring data in from your relational data sources into Hadoop in as easy a way as possible. So Hadoop has this great promise, I think, of just being a place where you can dump your data and start playing around with it without worrying too much about schemas and without worrying too much about controls around that data that you do with, say, a typical data warehouse or even sort of a data mart. What we've enabled you to do is to go out, find that data in those more traditional sources, and easily move that into your Hadoop system, and then do the analysis in the Hadoop system using this push-down approach that we've taken.
Great. So the next question is for Joel from Javid. What are the various roles of the members on your SWAT team? Would you recommend?
Yeah, that's a really good question. I mean, so when I used to work for Intel, we had what we called an integration team, and basically, and the same thing when I was at AVG, is depending on the campaign or depending on the project or depending on the needs at the time, we would assemble kind of the best subject matter experts to kind of join this kind of SWAT team. So, like I said, depending on the use case, we basically, for instance, at AVG, we had what we called a Tiger team. So when we launched our upgrade campaign, we had folks like the online marketing manager who was involved with that. We had, a product person who was involved with that. We had, an analytics professional who was on the team as well, and as well as, a DBA or a BI professional who would also be on the team. So I think it really depends on the project. But what's nice, I think, and not to push Alpine too much, but I think the way we've defined things is we really kind of think of people who are really, collaborating, who kind of need to be in the know and who can contribute, but aren't necessarily, doing the hardcore, analytics piece. But definitely, we make it possible for anyone to kind of come in and contribute. So I wouldn't necessarily exclude anyone, and I would just take it as a case-by-case basis.
Great. Thank you so much. I think that's all the questions that we have for today. Thank you for your time for joining our webcast today, sponsored by Alpine. Any questions or if you need additional information, please feel free to visit us at our site, www.alpinenow.com. Thank you so much.
All right, folks, and on behalf of O'Reilly Media, we'd like to say a big thank you to Alpine for sponsoring today's webcast. We also pushed out, folks, a URL to you all that's going to open in another window or another tab on your computer. It'll take you to Alpine where you can see more information about what you've heard today. And, folks, as we wrap up the session, we'd like to say a big thank you to today's speakers, Joel and Steven, for their great presentation and for sharing all their knowledge and expertise with us. And we'd also like to let you know that Alpine is the world's first collaborative code-free solution for advanced analytics on big data. Alpine's mission is to give everyone in an organization the power to create and share analytics instantly without compromise. If you'd like to try Alpine today, head over to start.alpine.now.com. Again, thank you, Alpine. Thank you, everyone. This will conclude today's webcast. Goodbye, everybody.
Awesome.